In this clip, we are going to prepare our clouds deep pass. So we saw in the last clip that our render for the cloud pass was split in half. So let's create another deep read node to import the first part of it. Here, inside the course material folder, inside the CG folder, clouds 1 to 8. So the simple reason I have a split render here is because the lighting department, well, here it's me, started rendering at the wrong resolution. So I stopped the render and then I adjust the resolution and rendered the other frames. I was about re-rendering the 8 first frames again. Then I thought that it would be interesting to show you how to manage this kind of issue in Nuke. Because I'll be perfectly honest with you guys, render passes coming from lighting are not all the time perfect, and sometimes you have a big render farm and sometimes to spend so you can re-render the CG. But the truth is that most of the time you don't have the opportunity to re-render the CG because the deadline is too tight to provide the final shot to the client. So you end up dealing with recomposed sequence and weird looking frames. But this is part of our job to be able to work in these conditions. So here, let's adapt. So first I will create a switch node to be able to switch from one of the deep read to the other one. So this is the first frame, right? So I plug the 0 and then I will plug the 1 here. Then I don't need that for now. For now, I just want to switch between my two read nodes. Then I will go to the frame 8 and I will create a keyframe in my witch. And then I will go to the frame 9 and I will create another keyframe with a value of 1. So this is it. Basically, I just put together these two guys. The problem here is, don't forget that the first part here is at the wrong resolution. It's actually bigger. So I will use a deep reformat node to bring it back to our current resolution. So we'll look for the deep reformat, this guy here. And this guy is working exactly like a normal reformat, but especially made for deep nodes. So that guy will just simply take whatever format the input node has and bring it to the format mentioned here. In our case, 960 by 540, but you can choose any format you want, of course. So now all my frames are working together. So I could use this bunch of nodes as my way to access my deep informations. But in order to optimize all that, I'd like to render a pre-comp of that small tree. So let's do that. So we'll create a deep right, and this node is like the right node, but to output deep informations. If you try to output deep information with the normal right node, it won't work. You really need a deep right. So we'll just delete that guy and I will connect the deep right to my switch here. Now, before rendering my deep pre-comp here, I'd just like to grade a little bit the RGB info of this deep pass, because the lighting department totally screwed it up. Yes, I know, it's me. Well, something went wrong and the light in my 3D scene ended up being so strong. Same here, I could have fixed the issue, but one more time, I think it's an interesting challenge to address. So we don't want these horrible looking clouds. Fortunately, this is 32-bit float EXR. As you can see, if I'm reducing the gain of my viewer, I'm starting having something looking better. So here, I can't use a grain node or a color correct node because these nodes work with regular images, not deep images. One more time, to work with this deep workflow, I will need to use a special deep node called the deep color correct node. There is other way to do it as well, where you will be able to use regular nodes, but I wanted to show you this one as it could be quite useful sometimes. So let's connect that node in between my switch and my deep right and drop the gain to 0.145 and a little bit the gamma to 0.66. This won't be the final color grading, we will do that later while comping our images, but this gives us a better start to comp these images. Now I can output this precomp, and I will specify the file path. In the course material folder, I will create a subfolder called precomp, and inside that folder, another folder called cloud deep clean, and then my file name, cloud underscore deep underscore clean dot pound 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 dot exr. Now I need to change two important things here. First, deep needs to be rendered in 32 bits. Otherwise, you will lose data accuracy. If 16-bit doesn't impact too much colors, technical passes like deep will suffer a lot from it. And there is no point to have deep pass if it's not accurate. The second thing here is that you want to include all your metadatas in your render pass. The deep position is calculated according to the camera position and its attributes. And these camera attributes need to be included in the deep file as metadatas. Default metadatas don't carry them, so switch that drop-down menu to all. If you are willing to have more information about metadatas and data types, I recommend you to have a look to my course at Pluralsight called Nuke Rendering. Inside the module called Main File Types, Codecs and Compressions, have a look to the clip High Dynamic Range Images and Floating Point Values and the clip The Open EXR. Alright, this is it. I can click on Render now, specify the frame range, and Nuke will render my brand new and clean deep pass for me. I will pause this clip here and I will come back when it's done. Alright, my render is done, so let's have a look to the results. So I will select that guy and create a new deep read. So I'm selecting that guy to jump directly to the render folder. So there we go, so I could select that guy here, the cloud underscore deep underscore clean, and click on open. And perfect, let's have a look. It looks great. The color correction is in it, and we have now only one file, which is way better. I won't delete these nodes for now as I may need them later, so for now I will simply disable them with the D key. And just to have a clean script, let's put these nodes in the backdrop and let's call it Deep Clouds PRC. Alright, this is it for this clip. In the next one, we will optimize the planes deep by cropping the image with a bounding box.